Is that better? Okay, so it looks like we sorted out. All right, so I want to talk about a couple of things that we've been doing for the last several years. Actually, the first part will touch on some of the things that I started with some amazing colleagues and students. Dima, you might have come across her work from Bristol, and then a couple of students that we have co-supervised, Isid and Hazel, where we started looking at, indeed, skill understanding. But let's start from the beginning. And I want to share this as an example of how the future looked 30 years ago. So this is a work by Steve Feiner, a colleague from Columbia University, and his students, the Karma system, where what you see here is one of the first demonstrations of augmented reality for assistive systems. And you might see in this picture, there's these triangles, they are everywhere, on the headset, on the device, and they're used for positioning and knowing where you are relative to these objects. Because of course, computer vision back then was not as advanced as it is today. And if you know where you are relative to these objects, then you can do things like this. You can superimpose objects like this 3D object that you see here, and hopefully that is going to help you to do things. This was 30 years ago, okay? I was very interested in this direction on how to resolve that first problem, which is the positioning problem. So I actually, as part of my PhD, I worked on some of the very first SLAM systems that use cameras and only cameras in order to position yourself. And if you know where you are, the camera knows where you are, and you know where the objects are, then you can start to do some of this augmented reality for real. But after all this time, after 30 years, and we have heard through the questions and the presentations today, we're still longing for that augmented reality assistant. And there have been amazing hardware in recent years that actually have moved the goalposts from the point of view of technology quite a lot. But we still don't have that device that we can just wear and we suddenly become experts on everything, right? And the reason, as we have heard through all these talks, is because the majority of people, including myself, we worked on this problem here, which is a positioning problem, and not so much on the authoring problem, on the content that you are going to show. And it becomes clear then that the real obstacles for assistive systems is that we lack the ability of creating the content that you're going to actually use for you to actually deliver what these assistive systems actually require. And one of the very first systems that in my team with colleagues in Bristol we built is precisely looking at how can we scale the authoring for this problem? And we essentially just stated perhaps the obvious that many people will have gone through the same type of problems that someone else is facing. How can we actually capture that information in order to relay that information to someone who actually needs to do that? And one of the very first things that we did, this is back in 2013 when we started this work, is look at how humans actually learn. And this links to what is known as the power of imitation, which has a very good neurological basis in the theory of motor mirror neurons. That if I see you doing something, the same neurons in my brain that will replicate your motions trigger. And that's very important because it means that I can copy you when you're doing things. And the interesting thing is that it goes really beyond just humans. So this is actually a video of a lizard watching another lizard solving a problem and then being able to actually solve that problem themselves. I will mute the video, but essentially this is a lizard watching this video, watches that other lizard solve that problem, which is opening that gate. And only after being able to do that, it's able to actually solve the problem. At first it hesitates, but eventually it actually remembers what to do. And according to an experiment by Dr. Wilkinson at the University of Lincoln, only those that watched the video were actually able to solve the problem, and those that didn't will take much longer or were not able to solve it. So that power of imitation, watching a video of someone doing something, is rooted in something super basic on us and even animals, right? So the very first system that we actually put together in order to offer help, which is the Glacier system, essentially exploits this capability. And back then, everyone in augmented reality was really looking at, oh, let's create these sophisticated 3D models in order to render the world, and only with 3D arrows and things like that, you were able to actually achieve tasks. It becomes very natural when you actually just watch a video of someone doing something. And so this is essentially what that original system did, was observing humans doing tasks, for example, setting up an oscilloscope. This is using Google Glass, so very basic. The system was self-contained. It actually decided when to capture, when to stop capturing information, but essentially was just recording videos of when people were doing things. And eventually you can then rely this information. You can capture multiple. This is an example of the video that you will look. You could capture multiple of these videos, and then you have a collection of videos of people doing things, which eventually you can rely to someone who is in front of that device. So Google Glass automatically recognize the object and match that view with one of the views that we have captured, and you were shown these little videos. Even with a very tiny Google Glass display, people were able to actually replicate the tasks. So, right, this looks like we have something that can offer help, and we can scale. But then the problems really start, which is you have all these massive collections of video, and then you have to decide which video to show. And the very first paper that we put together, CPR 2018, with Hazel and Dima, was precisely about how do you actually rank how people do things. So we had people doing a bunch of egocentric viewpoint activities, where it goes from surgery to baking to drawing, and then devising a system that was able to rank these videos in terms of expertise. And the follow-up work actually looked at how to identify moments within a video, so much more narrow moments within a video that enable you to understand when the person was doing better or doing worse. And I will use this video also to connect with the second part of the talk, because as you can see here, let's say this is just doing scrambled eggs. You see one person that at the beginning they look better. The second example, the person seems to be having difficulties, but as the video progresses, actually one person doesn't do as good as the second person who actually initially started having difficulties. And that also started to trigger a lot of questions on what the next steps will be. But with these type of systems, you're able to rank how people is doing for relatively complex tasks, using chopsticks or wearing a tie, and things like that. But there's still something missing, and actually many things that are missing from these systems. And what motivates this second part of the talk is precisely about these several moments that I actually avoided naming as a struggle, but there were actually struggle moments. And this is out of a great collaboration with Michael Ray and student worker supervising Shija, who just submitted his dissertation. We're very happy about that. And let me play another motivational video about struggle. So this is, I will let it play. This is an absolutely amazing moment, right? This is actually pre-verbal kids. They haven't learned to speak. They can recognize that you're struggling. When you're having a situation like that, you don't need to know about the task. You don't need to know about rock climbing or cooking or anything that you are interested in for someone to recognize that you are having difficulties. So this means that there is something very deeply rooted on our abilities to recognize others being able to, others that are struggling and us offering help. Because this video actually demonstrates two very important parts. The first part, the kid recognizes someone is struggling. And the second part, which is also super amazing, they know how to go and help. They know the moment they need to go and help, okay? And interestingly, this seems to happen even beyond humans. So in other primates, this is the example also by Wernicke, and now he's in the University of Michigan Social Minds Lab. Recommend, if you're interested in this, watch a bunch of videos that they have on this problem. But even primates are able to recognize when you're struggling, and they will go and offer help. So this is super interesting. I mean, for an assistive system, for an AI system that is meant to be helping you, we might not need experts that go and annotate our data. If you can do at least part of that through the recognition of struggle. And so I find this extremely important for any artificial system to actually, that it's aiming to offer help, to actually understand. Now, what do we mean by struggle? And actually, a couple of you during the poster session, the first question that comes to mind is, what do we mean by struggle? And I have to confess that I absolutely hate language. Language is one of those most horrible tools that we have found most useful. Because language is not able to fully describe what is out there in the world, yet we expect that we are able to describe and very neatly define many of these tasks. But let's remember that kid that is able to recognize that there is a struggle happening, and yet they are not even able to describe what is happening with words, okay? So struggle, admittedly, in the way we're handling it, is very ambiguous to define. But one thing that I am certain of is that struggle is not about errors. So it's not about you knowing the task and then recognizing that it's an error or mistake in the task, okay? Struggle is something far more fundamental. And just to keep talking about how struggle is different, struggle essentially, you can actually complete a task. Imagine that you're trying to bake a cake and make a mess in the kitchen, struggling all the way, but make no mistake in the steps, right? You can bake a cake, make a mess in the kitchen, no steps skipped, but still you struggle, okay? It's also possible to bluff your way and make lots of mistakes in the steps, maybe even complete the task, and not struggle. That one is slightly difficult to visualize, but hopefully you're staying with me. Importantly, and again, as argued before, is the detection of a struggle does not require task knowledge. And I think this has to be amazing for us in the community, right? Because we have all struggle, pardon the pun, on labeling data and being able to get experts that are able to go and annotate everything that is going on, and therefore do some of the things that we actually need to do. But at least a struggle, if it cannot offer some of the very valued tasks like coaching, for example, it might still be able to anticipate that errors are coming, or identify hotspots on tasks that 80% of people struggle, right? You can also benefit from the fact that you don't need to know anything about the task in order to identify it if we succeed at that general ability of detecting struggle. So struggle has many advantages for us to index on and to actually try to address. And in the first paper that I will be talking about, we indeed worked on 3 data sets where we can find many examples where people struggle but do not make an error in terms of the steps, or the person struggles but does not make an error, or they just struggle and make errors, right? So there is like a bunch of situations where struggle appears independent from error. And in the community, I do feel that we have over-indexed a little bit on the detection of errors, which requires all these other capabilities that are difficult to achieve. So the types of struggle that we have encountered in the type of tasks that we have worked with is things like repetition. So someone is trying to do something and tries and tries and tries again in a step, right? This is from one of our data sets, the pipes data sets. And the person just tries and tries again. So that's a repetition type of struggle. You can also have assembly errors. So again, errors and struggle may overlap, even if they are not exactly the same. Or you can just find people that simply stop and they just don't know what to do. And so to address the problem of struggle, we have introduced 2 data sets. The first one we just recently published in ICCV. The paper is called "Are You Struggling? Datasets and Baselines for Struggle Determination Assembly Videos." And it comes with 5 hours of recordings where we have annotated. We had an expert annotator. We also have 20 mechanical torquers per chunk of video, and we had thousands of chunks of video that were annotated. So we collected a bunch of data that helps us to understand about what people think of moments of struggle. And then more recently, we just put on archive this new work, which is the Evo struggle data set, where we actually look at the evolution of struggle. I will be talking about that. But this second paper has 60 hours of video, 18 tasks, so many more than the first video, and does things in a slightly different way. But from the point of view of the first paper, the ICCV 2025, we actually use these 3 different data sets. The Epic Tents data set, you might have come across that paper. It's people assembling, pitching tents, and struggling or not struggling doing that. So that's one of those things. And it's in that one, it's very easy to find that the fluidity of the motion of how the person is actually pitching the tent tells a lot about moments of struggle. Then we also have Towers of Hanoi game, where people is just moving blocks, if you know the game. And people, I will show some videos of the type of things that they do. And yeah, this is the type of videos where people go. So let me just go to this moment just for speed. So moments of struggle. So for example, here, the person is trying to put things together. There's a lot of head motion in there, back and forth, maybe looking at the instructions, maybe looking at the pieces. When the person is more confident, then you don't exhibit these hesitations in there. In the Tower of Hanoi, this is a very typical example. The person is actually hesitating, actually moving their arms, so a lot of energy being spent, trying to figure out what to do. Also a lot of head motion. Non-struggle is a confident move, fluidity of motion type of thing. And in the tent, this is actually the most complex one, the most ambiguous one. It's a non-rigid object, so it becomes really hard to handle and all that. So you have moments of struggle all the time, and so on. So on this data set, we actually used a 4 scale for annotating struggle that goes from definitely not struggling to definitely struggling and having intermediate steps of slightly struggling, slightly non-struggling. And so these are the definitions that were given to mTurkers and to the expert annotator. And we did a bunch of analyses. The paper covers a lot of ground in terms of understanding the statistics of the data and what the difference is between the golden annotator and the mechanical Turkers for the different data sets and so on. And we also did studies about binary classification of struggle. So we tested models. Can you actually classify the person struggling or not struggling? Or also classifying the nuance of struggle, like sometimes not struggling or almost not struggling to definitely not struggling. So the 4 scale that we have. And these models, this is not a huge data set. This was just early stage. We're more interested in just triggering the conversation about identifying struggle. In this data set, which is relatively small, admittedly, the classification accuracy is much better, much better when we do the binary classification of struggle. So are you definitely struggling and not struggling? Versus when we try to classify the 4 graded scale. And this is not unexpected, right? But there is still a bunch of ground to cover for this model to actually, for these models, we tested several, to understand that level fine-grained understanding of struggle. But the new paper, the one that we just released on arXiv, which is about the evolution of struggle, takes this into a couple of other dimensions. First, we have many more tasks and activities. I will explain a little bit more about that. But one of the key things of these new data sets is that we actually look at the evolution of struggle. So if I give you a task, which is, for example, make an origami object, the first time you try that, if you have never done origami, you will struggle much more than the 5th time or 7th time that you do that, right? So there is a natural evolution of struggle as you are progressing and learning more about the task than if we just give you one chance to do things, which is what the very first data set really was. So this is great, this is beautiful, because now we have a gradient of skill that even without any annotation, we already know, based on the statistics, that the examples on the last try are going to contain much less struggle than the examples that are at the top. So this could be very valuable information for training systems with weak supervision. On this system, we actually learn a lot, and several reviewers actually were poking at the way in which we describe and annotate the struggle in the first paper. And admittedly, this is not a perfect approach that we're following in the second paper. So I think there is a lot of room for the community to still decide how best to annotate the struggle. But in this case, what we did is, knowing that the expert annotator and the mechanical Turker annotators actually had a very high correlation, we say we can simplify our task and lives by just having one golden annotator annotate the entire 60 hours on the data set. This has pros and cons, but is backed from some of the evidence on the earlier paper. And in this case, instead of having a 4-scale annotation of struggle, we simply annotate instances of struggle, and then we cluster these instances to create these simpler moments when struggle is happening. And as I was saying, this new data set actually has 4 different activities: origami, tying knots, tangrams, shuffling cards. And within each activity, we also have different subtasks. So let's say within shuffling cards, we have 5 different ways of shuffling cards. And this is an example. So different ways in which you can shuffle the cards, and we put people through these. Some of the simpler ones, it will be much easier for them to do. Some others will attract more struggle at the beginning, and so on. So we have all this range of different tasks, different attempts that changes the level of struggle. And this is an example of filming the same person with the first attempt during origami, one of the subtasks, and then trying on the 5th time with this other one. So on the first one, it should be very clear that this person is struggling. There are pauses, there are changes, remakes, and much slower. In the 5th attempt, the person is much more confident, and there are no obvious signs of struggle in there. And we have run all this data through a bunch of different models, Action Former, TriDet, Retutorial. Some of those models may be improved by later models, but this is again just a baseline of where we are. And where we are is that these models are still, sorry for the pun, struggling to actually detect struggle, because it's a very nuanced task that is not easy to detect. We have done a bunch of other analyses on what happens if we train with everything but one of the activities. So we train with shuffling cards and tying knots, but not origami. What happens? So this is generalization. And there is much better generalization when similar tasks are trained. So let's say we found that shuffling cards is really different to the rest of these other tasks like origami and tangrams. And so generalizing between origami, tangrams, and tying knots is much easier than some of the other tasks. And this just speaks to the richness of the types of motions that are exhibited on these different data. And then we tested also what happens if we train with only the first attempt versus the 5th attempt, and so on. And the conclusion is that a variety, a diversity, and capturing struggle at all different ranges is much better than if you only train with one of them. In terms of the spatial prediction, these models do better in some of these activities, like, for example, tying knots. In this case, it's just not doing well. In some others, it overlaps much better. Overall, I think there is hope from the signal and also the motivation that there should be something very universal, very fundamental about the detection of struggle. And so it is arguably one of those things that we really need to index as part of the community if we want to escape that obsession of knowing about the tasks or having constantly experts understanding about what is going on. And if we achieve this, then of course, then we will really open a bunch of possibilities that are beyond just error detection and so on. And admittedly, even that this is an ambiguous problem, a very ambiguous task to do, that should not deter us from attempting to do this, because in principle, if we succeed, then we really unblock a lot of things. And we hope that the data sets and the ways that we have tried and tested from the point of view of how to annotate struggle really helps the community, and we can take next steps in this direction. All right, will this, I stop? Have you hear any questions?
So unfortunately, we're probably going to have maybe one question, because otherwise they might kick us out.
Yeah, that's okay.
So are there any questions that anyone would like to ask from the audience? Nice.
Great talk. Thank you very much. So I see a lot of the struggling because it's a repeated action, because the person didn't achieve the same thing, what they wanted on the first time, right? What about a place when they have to repeat the drill, like shooting basketball or doing multiple times? Do you think the ball doesn't basket is struggle. Sometimes it does, sometimes it doesn't.
Yeah, I think those are valid questions in terms of what are the limits of struggle. I will argue that in that case, it is what happens before the throw that can tell about the struggle. Maybe I'm not a basketballer, but I can imagine that the way in which you grab the ball, the way in which you jump or move or not move and jump, those signs of struggling or hesitating could be telltale signs that you need help and also your level of skill, even if you know nothing about the struggle. But the question is interesting because it involves an object, right, which is the ball that detaches from your body and then that does something else. But again, I will argue that is what happens before the throw that will tell a lot of the signs of struggle, if that makes sense.
I think we'll have to stop it if you don't mind after doing that as well. Thank you.
Yeah, happy to catch you. Thank you.
Appreciate it. Thank you very much.